I'm going to look in this video at exercise, I think it's 1E, on velocity time graphs and multi-stage problems. So I'm going to do a couple on velocity time graphs just to start off with. Now, the first one is we've got a hot air balloon, and we know that it's floating at a constant height before descending to a lower height. And we know that it descends with constant acceleration of 5 meters per second squared. So it's going down. I'm going to call that a negative direction. And it does that for 6 seconds. And then the burner is turned on and the balloon decelerates. So this means that instead of going faster and faster down, it's slowing down on its downward trajectory. So and then until it's no longer descending. So I'm just going to set up a wee graphy sort of thingy here. Okay. Now I'm going to call. Oi, don't do that. I'm going to call this axis my v, and this is obviously going to be my time, so time velocity. Now, I'm going to go down in fives, and I'm just going to take this as 0 as my original height. Now, obviously, it's not 0 meters above sea level, otherwise it's not going to be a hot air balloon, it's just sitting on the ground or something, right? But we'll take our original, where it is in the sky, as 0, because it doesn't say how high it is. So we're just going to use 0 as our reference point. And I know that it goes down 30 meters. Now, how do I know that? Well, let's have a look at the data we've got here. It's descending with a constant acceleration of 5 meters per second. So we're going to say at the beginning, it's at 0 velocity. It was at a constant height before descending. So if it's at a constant height, it's neither going up nor down. So we're going to call that velocity 0. That's where it is at 0. Then it's got a constant acceleration of 5 meters per second squared, and it's a downward acceleration, and it does that over 6 seconds. So we'll do this here, 3, 6. Okay, so after 6 seconds, what is its speed? So velocity, how do we calculate our velocity? Well, if it started off at 0 and every second it's increasing its speed in that negative direction by 5, it's going to be at 30. So we're going to have 30 here. And I'd use my ruler to join those up. Now this will be a bit dodgy probably. You get the general gist of it, right? Now, at this point, once it's at a speed of minus 30, in other words, traveling downwards at 30 meters per second, then we turn the burner on. And this is going to slow its downward process. Okay? Which means that the velocity downwards is going to decrease. Now we're doing this at 2 meters per second until it's no longer descending. In other words, until its velocity is 0, which means it's going neither up nor down. Now, how long is that going to take? Well, if we're increasing from negative 30 at an acceleration of 2 meters per second, it's going to take 15 seconds to get back to 0, right? Because 2 times 15 is 30, and we need 30 to make up for the negative 30 we've got. All right, so that means if it takes 15 seconds, what's 15 plus 6? 15 plus 6 is 21. So I'm going to carry on going up in 3s here. If you can hear my daughter crying, it's not because she's in trouble or anything. She has just been, she's just going to her afternoon nap, and she's decided that she would quite rather stay up. Okay. And there we go. That is where it will be at the end of the 21 seconds. Okay? So a key thing to remember, don't get confused. Sometimes people get confused. This is a velocity time graph, okay? So we're not saying that the balloon is back where it started at. That is not what we're saying at all. We're saying that the balloon's velocity is back where we started at, but we have, in the meantime, gone down quite a distance. So just make sure you're thinking carefully about what type of graph you're using. Now, let us move on to the next question, where we have a graph showing a motorcyclist when he starts traveling along a highway until reaching top speed, and we've got to find the distance in reaching that speed. Now, the key here is distance is the area under the curve, or displacement is the area under the curve. So, okay, we're going to go S equals, now this is a trapezium, and it's going to be half U, which is 10, plus V, which is our speed at the end of it, multiplied by the time, which you know this formula because we learnt it last week as one of our SUVAT equations. Okay, well in this case that is going to be half. Our original speed is this one here, that's where we started, so that's 10. Our final speed is this one here, which is 30. And the time that this took was 8 seconds. So we're going to have 4 times 40, which is 160 meters, should be our answer. All right, we are now going to carry on to some other types of questions later on in the exercise, multi-step problems. So let's see how we get on with this, this stuff. Okay, let's have a look at number 9. A car accelerates at a constant rate, so constant acceleration for 10 seconds, starting from rest, which means 0 meters per second, and it reaches v meters per second. So rest is u, v is v, obviously, and then remains at that speed for a further 20 seconds. At the end, 300 has been traveled in total. Find the value of, and that's come out, it should be find the value of v. Okay, well you know that the distance is made up of 2 parts. Part 1 is going to be the formula for this formula here, half u, our original speed, plus our final speed multiplied by the 10 seconds. Okay, so that's part 1. But then there is also part 2 where we're traveling at a constant speed, and that will simply be v times t2. I'm just going to I'm just going to rub this out because I shouldn't have just put that 10 in there. I'll call it T1. It is 10 though. Okay, so S equals, and in part 1 we know that our original speed is 0, it's at rest, plus V, which we don't know, multiplied by 10 seconds. Part 2 is V, again we don't know, but we're going to try and find the value of it, and T2 is 20, so we'll call this 20V. And I should probably rub this S out because we know that the total distance is 300. And now we can start putting everything together. On this side here, we're going to have 5V plus 20V. And so 300 is equal to 25V, and thus V is equal to 12 meters per second. Okay, well, let's take a look now at the next question. And for this question here, we have a car at rest. Let's see. we have a car at rest, accelerating at 5 meters per second squared for 4 seconds. So it's at rest at the beginning. Then constant velocity after that. At the instant the car stops moving, a truck passes it. And we know that the truck has a constant speed of 22 meters per second. And after 10 seconds, the truck starts slowing at 1 meter per second until it comes to rest. Okay. Let's take a look at all of this data here. We are trying to show that the velocities are equal after 12 seconds. So let's look at the car. Okay, what do we know about the car? Well, at 12 seconds, the speed, what is the speed going to be? Well, we know that it starts off at 0, and its acceleration is 5, and it accelerates for 4 seconds, and therefore we know that it reaches a top speed of 20 meters per second, and we know, according to this, that it continues at a constant velocity. So, at 12 seconds, the car is 20 meters per second. Now let's look at the truck. Okay, so the truck starts off at 22 meters per second, and then after 10 seconds it starts slowing down. So we're going to use the formula V equals U plus, plus A T. Now, V is what we're wanting to find. It is at 12 seconds. We know its original speed is 22 meters per second, and we know that it's slowing down at 1 meter per second, and we know that it does this for 2 seconds, and that will get us at to 12 seconds. So altogether this is going to give us 20 meters per second. So we have now proved that they are equal at 12 seconds. Now that leaves us with the second part of A, which is to find the maximum distance. Hence, find the maximum distance. Well, the maximum distance is going to occur at 12 seconds. Now, why is that? Well, let's think about it. At 10 seconds, we know that the cars reach 20 meters per second, and the truck is at 22. But the truck is slowing down and it reaches the same speed as the car at 12 seconds. So that is the point of greatest distance, and from then on, the distance is going to get closer as the car is now going at a faster speed than the truck. Okay, so all we need to do is go, all right, what is the distance of the car? Let's go car. It's going to be made up of 2 parts. It's going to be 1/2 U plus V times T plus, and then once it gets to the constant speed, you're going to have V multiplied by the second time T2. So in this case, we could say S is going to be 1/2, and we know that U is 0 because it was at rest. And V, we know it ends up being 20 meters per second, and we know that the time is 4 seconds for this, and then we're going to go, well, V again is 20, and then for the second part at 12 seconds, so we're going from 4 to 12, which is 8 seconds. Now when we add this all up, we get 40 plus 160, which is a total of 200. That's my car. And at the same point in time, the truck, let's have a look at that. So S here is going to be equal to, originally this is at a constant speed, so it's going to be VT, or maybe we could call it UT, I guess. its original speed, and then it's going to slow down, and it is going to be our original speed u plus our final speed multiplied by the time. Now in this case, we know it's going 22, and it goes like that for 10 seconds, and then it starts slowing down. It starts off at 22, and we know that it gets to, whoops, that's a plus there, gets to 20, and it does that over 2 seconds. Now if we add this up, we get 220, and then we're going to get plus 42, which adds to 262. So the distance between the car and the truck is 62 meters. Okay, at this point, guys, we need to show that the distance covered at a time ts from the start by the car and by the truck for time is greater than 10 are given by these two different formulas, and then find where the car passes the truck. Now, I'm just going to jot down some of the Suvad equations, which we needed to be familiar with. We've got this one. We've also got this one. And we've also got this one. It's an equals there. Those will probably do us, I think, for what we're trying to achieve here. Now, I think with the car, if I remember rightly, we are starting at rest. So the first part of the car equation is going to be constant acceleration, and let's see, we know that after 4 seconds, how far has it traveled? Well, it's going to be half u plus v times t. That's the first few seconds. Then we know that after those first 4 seconds, we're going to be traveling at a constant speed. We know that's going to be 20, and it's going to be for how long is it going to be? Well, it's going to be time minus the first 4 seconds. And what we're trying to say here is that this bit here doesn't start until you reach 4 seconds, then it starts being counted as part of the distance. So that's why we've got to have the minus 4. Now we can actually simplify this. We can say half, and u is 0, v is 20, and the time is 4 seconds, okay? And I'm going to leave this like this because that seems to be how they have it. And when we simplify that down, we get 40 plus 20 bracket t minus 4. Now let's move on to the truck. The truck starts off and it's going at a constant speed of 22 meters per second, and it does that for 10 seconds. Now then it changes over, and we're going to use what formula could we use here? We could use this one here. So it's going to be ut, so that's its original speed, and then plus half a t squared. Now this will be 220, but again I've got to take into account with these t's here that this part of the equation actually doesn't start until after 10 seconds. So I probably need to adjust that slightly and say it's actually going to be u into t minus 10. At 10 seconds, this part starts ticking over, plus 1/2 a into t minus 10 squared, right? Because this is the second part that starts at 10 seconds. So when we do that, we end up with plus 22 into t minus 10 bracket plus, Now, the acceleration is -1, so I can actually just change this to minus 1/2 into t minus 10 all squared. And then to find the time at which the car passes the truck, we've got to make these two things equal, which is going to be really annoying, to be honest. On this side, I'm going to go 220 plus 22t minus 220 minus 1/2, and then I'm going to put a bracket here. I'm expanding my brackets, t squared minus 20t plus 100 equals, and on the other side I'm going to do my pink one, which is 40 plus 20t, I'm just expanding those brackets, minus 80. Okay, let's have a look. Well, let's have a look what we get here. We're going to get 220 plus 22t. Oh, look, this is going to cancel out with this 220 here. So 22t minus 1/2 t squared plus 10t minus 50 equals, and then I got 40 minus 80, which is minus 40, plus 20t. Bring everything over to the left-hand side. Minus 1. Why have I got green here? Sorry. So it should be minus 1/2 t squared plus 32t minus 50 plus 40 minus 20t equals 0. Minus 1/2 t squared, and then we've got, I think, negative 8. Ooh, hold up. Plus. Oh, is that 50 or 50t? No, it's not. Okay, hold up. Back up the truck. So this should be plus 12t, I think. And then minus 10 equals 0. To make life easier, I'm going to times everything by negative 2. T squared minus 24t plus 20 equals 0. So we might use the calculator to solve this one. And I'm getting an answer of t equals 23.6 seconds. Now, if you put in a negative, if you use the quadratic formula and use the negative, the other answer you get is 0.4 seconds. So I'm going to go with the 23.6 there, because it was for greater than 10 seconds.